Find the nth term of a sequence. Let n starts at 1. So I have a sequence right there. This time, I didn't tell you what an equals to. So I want you to tell me that what an equals to. So that means you read the given numbers and then you have to find out the pattern. They say n starts at 1. Okay, then n equals to 1, n equals to 2, n equals to 3, n equals to 4. So the technique is you have to go ahead, write something down on your paper, and then just keep changing it. So when n is equals to 1, when n is equals to 1, I cannot just put a 1 and a 1 right there, right? That is not equals to 2 there. So just to give myself a 2, I need to add 1. This one, I need to add a 2. So that is equals to 2 over 3. Okay, so when n equals to 2, can I have this? Can I do a 2, 2? Can I add the same quantity? Plus 1 plus 2. So that is equals to 3 over 4. Okay, that looks good. 3 over 4, that works. Okay, when n is equals to 3, how about I have 3, 3. Add 1, add 2. Does that work? That is a 4 over 5. Okay, that works. So that means I can write an equals to n plus 1 over n plus 2. And then when n equals to 4, you have a 5 and 6. So that is your sequence. Sometimes these things can be very complicated. So if you have this on the exam, you have to, hope that you don't get a very complicated sequence. Okay, the next one, I would like to show you one that the negative sign alternates. 1, negative 1 over 4, and 1 over 9, and then 1 over 16, that is in negative. So this is n equals to 1, n equals to 2, n equals to 3, and then n equals to 4. And then this one keep on going. So let's say if I do a negative 1 raised to the nth power, does that work? When n equals to 1, no, that is not going to work. So this one is a no. How about negative 1 raised to the n plus 1? So when n equals to 1, okay, 1 plus 1 equals to 2. The first term is 1. And then when n is equals to 2, I have a negative. When n is equals to 3, I have a positive. When n is equals to 4, I have a negative. So that works. And then also, this works as well. N minus 1, that works too. So when n is equals to 1, that works. When n equals to 2, when n equals to 4. So that works fine. And then the 4, 9, and the 16, that reminds me the power. So I can do a 1 over 1 square, 1 over 2 square, 1 over 3 square, this is a square, and then 1 over 4 square, that will work. And then including the alternating term, I can have an equals to negative 1 to the n plus 1, and then 1 over n, this one I can do an n square. Okay, that will work. Okay, that is another problem. How about let's try something that has a factorial in it. I have 1 comma 1 half, 1 over 6, 1 over 24, 1 over 120. So this one, I told you, this one has a factorial, but on the exam, nobody tells you that this one has a factorial. So therefore, you have to do a lot of practice to train your number sense. You have to do a lot of practice to train your number sense. Okay, factorial. Factorial, so 4 factorial, that is 4 times 3 times 2 times 1, that is equals to 24. So this one, they have n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5. Also, 3 factorial, 3 times 2 times 1, that is equals to 6. So what I am thinking, that this is just an equals to 1 divided by n factorial. So that is your sequence. So if that doesn't work, then you have to do some modification, like let's say add 1 plus 1, those kind of modification. You have to keep changing it until that works. Okay, last one. How about this? I give you a 1 over 2 times 3, comma, 2 over 3 times 4. comma, 3 over 4 times 5, comma, 4 over 5 times 6, and then keep on going. And then this is n equals to 1, n equals to 2, n equals to 3, n equals to 4. So I can see that the numerator is just equals to n. Then I need to start trying. So let's say an. When the numerator is equals to n, that works. We can see it. How about n? What is the relationship between 1, 2, and 3? Can I do a n plus 1 and then a n plus 2? Does that work? When n is equals to 1, that works. Okay. When n is equals to 2, I have 3 and 4. When n is equals to 3, good. When n is equals to 4, good. Okay. Then this is your sequence. Oh, by the way, this one, is that converge or diverge? How do you answer that question? So now you have a sequence, converge or diverge. Then you have to do the limit as n approaches to infinity. And I highly recommend you to multiply the numerator. So that will be n squared plus 3n plus 3. So since the highest degree in the denominator is 2, I will divide each term by n squared. And then that leads me to the next step. I have limit n approaches to infinity. N divided by n squared. I have 1 over n, and then this is a 1 plus 3 over n plus 3 over n squared. All the little fractions becomes a 0 because 1 over infinity, and similar. 1 plus 0, and then this is equals to 0. So that means as you look all the way to the right, when n approaches to infinity, these terms are just 0. So you have a bunch of zeros as you look all the way to the right. So therefore, we say this sequence converges to 0. Alright, so that is the end of this video. If you like the way I explained this, give me a like, subscribe to my channel for more contents like that, and I will meet you all in the next video. Signing out.